Welcome back to our series of solution and explanation to competitive coding. Today we are going to solve LeetCode question number 206, that is reverse linked list. So this is pretty much like frequently asked questions, so we should be familiar with this one. Okay, so what the question says, let's see. So given the head of a singly linked list, reverse the list and return the reverse list. So we are given the head of a singly linked list and we have to reverse the whole linked list and we have to return the reverse linked list. So what is singly linked list? First we should understand that. So they have given some general idea of what is singly linked list. So singly linked list could have some value, that is it could hold some value and it could have some reference to next node. So in doubly linked list we have reference to both next and previous node, but in single linked list we only have reference to next node. So that is the problem. If you have doubly linked list, we didn't want to reverse the list because we can traverse it like from the previous pointers. But in this we have only next pointer, that is each element is pointing to next element and it doesn't have any record of previous element. So like in example 1 we have given a linked list, that is 1 is pointing to 2 and 2 is pointing to 3, 3 is pointing to 4 and 4 is pointing to 5. And we have to do like we have to make our 5 as our head, and in the question we have given 1 as a head and we have to make our last element as 1, and in the solution we have to make our 5 as a head and it should point to 4 and 4 should point to 3 and 3 should point to 2 and 2 should point to 5. So how it could be done, let us see more graphically to understand it in better way. So suppose this is our example linked list. So what we have to do is that, yeah, so initially this is our head and we have to make this one our head and it should point, and if our last element is pointing to null, so our first element should point to null and every arrow that is a reference should be reversed, that like in this 1 is pointing to 2, in our solution 2 should point to 1, and 2 is pointing to 3, in our solution 3 should point to 2, and so on. So what we have to do is that first we have to make our head, that is it is the last element, that is it should point to null. So if we change its reference to point to 2 instead of pointing to 2, if it would be pointing to null, we will lose our reference to this whole linked list and abandon this linked list. So first we have to make other node that could hold the reference to the rest. And suppose we have created a node as called as next. Okay, so this is our new node, we call it as next. And now this node will be used to point our abandoned list. Or okay, so now if we have to change our reference of head to some other node, we can do it easily by just doing simply this node, next node will point to our head, now the abandoned node, and our head will point to our previous node. Okay, we can do like this. Now what the case is that our next is pointing to our abandoned list and our head is pointing to previous or null node. Okay, so first we have to create a previous node and then we have to create a next node and then make our head point to our null. Then what we can do is we have to make like our next node, that is our next node should point to the previous one. So we can do it like whatever the element in the next contains should be good. So let us do some coding side by side so that you can understand it in a better way. So first we have created our prev node, that is list node prev equals, it is null initially, and then we have created our next node, that is list node next equals, it is now pointing to head.next. What is head.next is pointing to head.next. Let me, okay, and now what we have done is that make our head.next equals to what is in our previous prev. Okay, now we have done this. Now we have to make our second move. That is, now we have to do that so that the next node, the next element, could point to the previous one. So we can do it by moving our head to next and previous to head, and do the same thing, that next should be head dot next and head dot next should be previous, in order to make, if we directly do that, this next node will point to this one, then we will lose the reference for the remaining. So what we'll do is that we'll first, now our priv is referenced by our head, so we don't have any fear of losing the priv. So now we can change our value of priv. That is, we can now make our priv equals head, and now our head could be head equals next, whatever the next is pointing to. So what we did is basically, suppose, now our head is now pointing to null, and second thing we do is that we generate a new node that is pointing to our next element, to not lose the whole list. And then what we did is we move our head priv from null value to our head value in order to not lose our head, and our priv is now here, and now this will become our previous node, and our head will move to this one. Okay, and we'll do it, and then we'll have to iterate it over again and again to make the same thing happen. So what we have to do is that now we have to move our next to head dot next. So we have to somehow put here while loop something. So we have to do while, sorry, black. Okay, so we have to do something like that. Okay, so while head not equals null. So why we did that, you'll understand in a minute. Okay, and we'll have to do something like this. Okay, now it will iterate over and over again and again in order. Now let us check this logic if it works or not. Now suppose we are on this node. No, next time what will happen is that, suppose now our next will do is that our next will no longer point this node, it will now move to this one, because this is now next dot head. And again, what will we do? Well, the next step is that head is this, head dot next will point to priv, which is this one, and now our priv will be head. Priv will move from here to here, priv, and now head will move from here to something here, edge head. Okay, now again we'll do the same. While our head is equal to null, now our pointer will no longer, next pointer will no longer point this one, it will go for this one, and our head dot next will point to priv, that is this one, and again our priv will become an head. From here it will go to this point, and our head will become head dot next, that is this point. Okay, let me write this very clearly. Okay, Control Z. So now our new head is this one. Okay, for the last time, again we still not find the null value in the head, so we do it again. Now our next pointer won't call this one, won't point to this one, it will now point to this one, and the same will happen. Our head dot next will point to now priv, and our priv will move from here to here, that is this one, last node, priv, priv, and my head will move from here to the null value, that is head dot next. So now finally our head is here, and we now find the value of head equals null. Now we don't iterate it over again, and we can return our priv value now in order, and we can see that each of our node is like pointing to the previous one, and our list is finally reversed. So let's implement this logic in our code and see if it works or not. So what we did is we create a new node, that is list node, something like priv, we call it priv equals initially null, and then we do some while loop while our head not equals null. We have to do like create list node, something called next equals, it will contain the value of head dot next, and now we can do is like head dot next could point to the previous element, head dot next could now point to previous element, and now our previous could be value of head moves our previous, and now head could be our next, and we can simply return our previous, return previous. Okay, let me check if it works or not. There are some bugs. Okay, forget to put semicolon. Let me check for other typos if there are. No, it did work. Now let's submit our code to see if it is optimal or not. So yeah, it is 100% faster and little bit more memory used. No problem, but it is one of the most optimal solutions. If you have a better solution, do comment in the below section, and again, thanks for watching.